of battery, or almost ran out of battery, and I paused the video and forgot to unpause it, so I'm proceeding now. What I last did was showing the splash screen, and now I want to show you some other things. Essentially, what we can do is to create a named pipe, like this, and give it commands, just like with psplash, where we saw like how the progress bar progresses. But for that, we need to define the progress bar. So I did a couple of things. I provided also a configuration file, and I call it fbsplash.config, where I also moved like the image more down and more to the right. And I said, hey, have a progress bar that when it's empty, just make it entirely green. Its height will be 50 pixels, and this is where you will position it. So you will see if my resolution is bigger than that it will just be somewhere like in the middle or in the side. So what I can do is get this configuration file and get the pipe, and look what will happen now. So basically right now I don't really see anything, but I can see that like I drew something on top of that. Okay, and let me just see that I ran it like properly. Yeah, and I want to see that the config file is what I wanted to show. Yeah, so that looks fine. So what I'm going to do is like start echoing, let's say 10 into 10 fbsplash FIFO. Okay, so look what happened. Like I have like this progress bar, and I can see that it's like a little bit gray. So now I'll do a little bit more. I'll echo, let's say 30, and we can see that it progresses. I'll echo 90 just for fun. If I echo something that is more than 100, I think that it will not do anything. And I can also take it like back in time if I remember correctly. So now it's 80. I'll put 100. It will not be entirely full, I think. And there is always like, like the drawers. But we're convinced we can draw things like to the graphic, right? And the other thing I can do is just do exit, and then the process itself will leave. However, as you probably know, then it's not, the frame buffer doesn't clear itself unless somebody helps it to clear itself. Okay, so this is another example. Now I want to go ahead and show you a couple of things with a very simple library called FBG, just for fun. I run this one and look how nice it is. It moves, it looks pretty graphical, and I will add to it, sorry I quitted it, but let's run it, and I will add to it background foreground, earth, and you can see like this flickering here, what's going on. I'll even be worth, I moved it and add to it like flags. So we have very neat graphics, you can see that, right? But all of these three programs are trying to compete between themselves, okay? And each one of them thinks that they have like the entire context, in this case the frame buffer, in this case the display, to themselves, and they just grow. But you can see that the graphics are like very, very, very nice. I'll get rid like of the first and the second ones, and look how nice it is. Yeah, so we can draw pictures and draw rectangles, or draw like a boot logo. We can do a lot of things if we have like it's called like engine many times, the engine that computes like the moves and how to do. So this requires computation. So if it's something like extremely, extremely, extremely like sophisticated and it looks amazingly, then the CPU is going to work very hard. It will need to probably multiply a lot of matrices, and this is a very strong motivation like for using another piece of hardware called the GPU, graphic processing unit, that knows how to do things in a very efficient way with a lot of parallelization. And this is also a subject of the next talk that Vadim will give like on Vulkan. So this is what we have here, and I think it's like pretty nice. Okay, So back to our example. We showed a couple of ways to plot to the screen, and I just want to show you like how the thing that provides like this very nice library works, which is pretty nice as well. I mean, it almost doesn't do anything. So let's see the minimal example that it gives. So yeah, we can also look like at the source code like a BusyBox. I will not do it right now. I'll try to make it like faster, but let's see the example that it gives. So the example would be, maybe I already covered it, but the example would be something like this. It would be, I mean, one of the nice things that I like here. Okay, so this is the last thing that we showed actually. Okay, or at least so I think. So I think we showed this and showed like the fbsplash, and I think this is where within the previous video. And now I showed that we can also show up the progress bar. So basically, I said whatever is here like with Word, we saw that we can bleed and we can do graphics, and maybe then there are libraries that can do things that are much more like advanced. So there are some very known libraries for font rendering and like for 2D rendering, like from in the GTK framework called Cairo, Pango, very used. There is Qt, there is OpenGL if we can use hardware acceleration features. SDL2 provides all kind of constructs as well. LVGL, I'll show a nice demo of it, but also enables a lot of things. It's quite popular in the embedded world. So there are tons of graphic libraries, all right? So, but what they do, how they're implemented, is of course different from one to one. Some are more powerful, some are less. FPG is not so powerful, but there's something very simple about it. I made like a little example and a little pull request just to be able to cross-compile it, to show it in several architectures, and to be able to build it statically, because the make file was not there. I hope it is accepted. Otherwise, if you want to experiment with it, you can just take it from this fork that I do, although I never do forks. And the idea here is that if we have like a frame buffer, we can use and compile like that easily. In this case, like it would be a tiny example. This is what I'm showing here. I just got some of the code and comments. We include standard includes. We include two includes from the libraries, graphics and fbdev. We open. We get a context. The context also like opens dev fb0, whatever frame buffer device is. And look at the API here. It's like so trivial, and this just going to grow like one rectangle via a library. So we don't need to understand what the kernel does. We don't need to go ahead and figure out what is the structures that we need to provide when we want to work on the frame buffer device. And that's like just what it does. Like it clears like a background, it grows a rectangle, and it flashes like the buffer, like it writes like to the screen. There's the concept of double buffering in Android, also like triple buffering, which is meant to avoid something called as like a screen tearing. I'm not going to get into it in this lecture, but if you see flipping, then this is like what it aims to resolve. Now this is what I showed pretty much before. So now a couple of words about LVGL. LVGL is a very popular library in the embedded world. There are other libraries as well, that some of them have this kind of licensing, some have other kind of licensing as well. LVGL is open source. It has very good demos actually in Zephyr, which is also why I like it. It works in Linux. It's pretty nice. It has a simulator that enables you to test a lot of like demos. And they also have, like from the couple of last years, they also have some nice demos, like they have it like in WebAssembly, so you can see some of the APIs. Maybe I'll do that. So I'm not going to spend too much time on it, but look at this. Like this is an example that you would have if you run it like from your Linux or Windows. You can see something like this on SDL. And here they did like the adaptation, they build it like with WebAssembly, put some JavaScript around it, and look what you have here. So it's pretty neat as well. Okay, they give you like the example. I mean, it looks nice, right? It looks really nice. So it is nice indeed. And one of the nice things that it can provide you is that hey, if you have like drivers, hey, this is how you access a file system, or this is how you access a particular display type. If it's connected via SPI, no problem. If it's connected via I2C, via GPIO, when we don't support it, no problem. Implement it yourself, tell you output a graphic, and so on. So it's supported in Linux, but there are two things that are a little bit annoying about it. Like when you want to set up the code base, it's already pretty big. Like it's over 450 megabytes. It's not as bad as like Vulkan, which is like 2 gigs, but it's still and not so amazing. And if you want to make it work with the Linux frame buffer, you need to work really, really, really hard. It's not so trivial, although there are all kinds of examples. There is like another project that they provide that is like for the Linux frame buffer, but you still need like a lot of libraries, and it's not as light as you would expect, and it's not as easy as you would expect. So you need to work with it, which is nice. We had a nice host that is also like a distributor of Qt, like in the meetup. So I actually did prefer to concentrate on Qt, but there is a demo that runs on the frame buffer as well. I think I put it like on YouTube already, but if not, no. So Qt, what I do like about it is that it provides a lot of functionalities like the Bluetooth, like serials, and I put an entire video that says like, hey, how we do like a Bluetooth scanner like in Qt, like how it all integrates from within QEMU. So I'm not going to talk about it now, but assuming or hoping you will see it for yourself, one of the nice things that it provides you is the ability to run over all kinds of backends. And I want to show you something actually. What I'm going to do now is run qtcreator with a linuxfb buffer. Okay, it has advantages and disadvantages. Like if I go now and run it again, did you see like the quick pop-up? If you pause like this video, then you will see that it shows something, but because this is the disadvantage, there are no like Windows Manager, and I mean usually the application expects that there would be a window manager that takes care of things for you. So Qt now doesn't. qtcreator, like the program you use to actually build Qt code with your IDE, you do it also without IDE. It expects to be running like on a desktop environment. So if it doesn't, just know that like some weird things can happen. But with an OpenGL backend, it looks a little bit better. So actually, there is a chance that there's something already running in there. But I'll show like this backend in a bit. Yes, I just put like the wrong param, but look, I mean, now I ran it. There's enough information about this in other things, and I'll go, for example, I'll just prefer like to use the keyboard here because I have 2 cursors. Like if I want to go take like a new files or like a new project or something like that, then it's pretty much doable. So it's pretty nice. It is very nice. And you know, I have input, output, everything is fine, hardware acceleration, even control Q works here, like the frame buffer did not clean itself, but with the eglfs it does clean itself. And it's pretty awesome, okay? So I'll show a couple of demos later. Just one important thing, I showed it like in the videos also. For this last demo that I showed, just so you know, like I already have like quite a big support for quite a few things. So this is what I showed like in the beginning of like the meetup, where I showed like a desktop environment. So this one, and the kernel in it is a kernel that is like from TCG Devos that includes much more things. Okay, so we can recognize it in my examples, at least for the time of recording, by seeing that the version is 6.10, where when I use the other kernel, it would be, I'll just do uname, 6.11.0 RC2. Okay, so back to our examples. So I showed Qt, but back to like some for examples. I do want to go and show you LVGL, okay? And I want to show you other things. So Qt, LVGL, they use quite a lot of libraries. They use quite a lot of libraries, and I already showed it. Qt can also like manage input and output. So if they use a lot of libraries, it means that it takes a lot of size. So we already showed like what can be achieved without too much things in our init from fs example. And if we see what is like the size, sorry, not of this one, like sorry, like if we look at everything including the mount point, then it's 30 megs. Out of it, like our examples, the statically linked examples that we had here, that are both these ones, where we have also like a picture that is like a little bit big. It could be much bigger, like the banner. So it's 7 megs, and it has a couple of examples for DRM, which are like 3 megs. So it's linked with all kind of things. And linked with libc and with and with libdrm, but it's statically linked, so executables are much bigger. If I looked at the full-fledged environment, and this is actually using an image, so I can do it. Look what it's used, like 4 gigs. With qtcreator, with the GNOME I put there a GTK, even without like the full recommends. I have a Mesa for OpenGL, I have Mesa for Vulkan. So there are a lot of dependencies. So there are two things. One, the file, like the packages that are installed, that are okay. But there's another one also for a minimal system, and I show it on other videos, like how I troubleshoot, and you should watch it. It's a very good debugging exercise. If I started with a minimal kernel, I don't put C groups there, then systemd would not work. If I don't put mutex, then I think fbsplash would not work, or bsplash would not work, or something else would not work. If I don't use Unix domain sockets, I cannot use dbus, I cannot use X server, I cannot do a lot of things. So I really need to understand what are the components, and I really need to know like where I'm going. Like it's super important. Otherwise, I can be extremely bloated. Okay, so it's something that are really worth knowing, and this is also why I make this. So if you want to work and research and see how things go, one of the recommendations is do something like I did, like keep some kernels aside, run with QEMU, keep images aside, use network mounting if you're super not sure, but know that you don't need to write all kind of things. And yes, you will need to figure out what are the configuration options that are needed. Otherwise, some very basic things will break for you. And this is in the other videos that I put this week on YouTube. Okay, I don't know when you listen to this, but the week of August 14, 2024. So I prepared the demos, and there's the way to that like in the YouTube. Okay, so we work with QEMU, but you need to also work with hardware that you know. And later also, when I also talked about it in the disclaimer sections in the previous section, that you need to understand what hardware you use, and if you want to use it in a VM, it's better that you would have another graphics card, and that you'll be able to do like a complete pass-through and assign it only like to the guest. And this particular device that I have, I have an Intel GPU. SRIOV is not is not in the main line of the kernel yet, so, and I did not want to install other device drivers. So I'm just waiting for it. So this is why I also wanted you to see like artifacts or stuff like that. So minimizing, deciding what configuration options go, and seeing it, how it goes with what you actually need to do the work is mastery, and you can already see how much work it can take and how much work I put into doing it. So I already like predated this slide, and I showed you like an example with input like with qtcreator. So I will not show another example that I actually showed like in the meetup itself. But here's the thing: what if I just needed something simple or small, and I did not need window management, I did not need any other application. Maybe I just want a kiosk device that can get something and display graphics. Then I'm almost done. I could have like a full system that does my needs, but I probably also need input. So here's the thing: if you just put, and there is an entire video about it, like you configure the events that you need in the Linux kernel, configure fdev, config input fdev and configure and give the right parameters for your input devices. And this I also showed in the other videos when I did cat to dev input event 1, event 2, and you see what happens when you move the mouse or when you enter something on the keyboard. Then when you have this, you can implement like your own environment for the application. And if you really want it, you can implement your own desktop-like environment. But of course, that has done it for you. The problem is that everything is like very, very big in sizes. Okay, so let's very quickly see some other examples. And this is a little bit of a different example. I'm going to get rid of my of this one. Bye bye. And I'm going to run something that uses like the same kernel, but is a little bit different. So I'll also put this one here. I do not want to completely maximize it. Okay, that's good enough for me. And what you see here is the graphic like from psplash. So I'm going to make my life a little bit easier. And here what I have is a fully fledged environment. And in the full-fledged environment, I have, for example, this UGFX framework that shows me some graphics that it paints along with its own splash screen. And I also have like LVGL example, which is also like pretty neat. So look how nice the graphics are, and look how nice like this looks like. This is the widget stem of LVGL v9. So it's pretty cool, right? And in addition to that, I could go ahead and do here. I will copy and paste for myself. This is a cute widget that look how it goes. Like so, we have here like the mouse. Even the button is cut. And this also happened yesterday. Like when I resized like the window, and it showed some black screen. But we already saw this before, so I'm not even going to bother over it. Okay, it's not so interesting. I'm running it again. Yeah. So here we have input, output, and everything is good, and everyone is happy. I did escape here. This was the problem actually. And this way again like that. So we have proof that we can also use like input here, which is pretty nice. So the way input works, there are exposed device drivers. One can go and pull the device, see what is the event, translate the codes, and everything is great. We've already seen desktop environments. I have an entire talk about KDE. There are also lightweight desktop environments that are not so lightweight. XFCE4, I'm pretty sure this is what comes with Raspberry Pi OS. It used to be called Raspbian. LXQT is supposed to be lightweight. It's based on Qt. Well, they are lightweight in a way, but they take a lot of disk space. Like each one takes over like a half gig, even without the recommend, if I'm not mistaken. And one of the nice things also like about the other framework, Qt is very powerful. We already saw that we can run it like from the desktop. But one of the nice things is that also GTK performs a way like to run things on the Linux frame buffer. But let's be honest here, nobody expects you to run without a desktop environment, or at least without like a window manager, okay? So Qt does have some advantages on it, because you can write like the same code and run it also in like, not only in other display environment or backend environment, or what Qt calls a QPA platform, but you can also run it on other operating systems, which is pretty nice as well, like UNX, like Windows, actually also like Android, WebAssembly, but you'll see a lot of projects that just build and translate WebAssembly because there are like external tools that do that. So we already seen it in other videos, like the desktop environment from scratch, and I will show it after I talk a bit about hardware acceleration again. So just clarification, if it was not clear enough, almost everything that does something significant will take you a lot of this space, okay? So I don't like it. Sometimes it's a necessary evil. You need to be mindful of it if you want to design and optimize embedded systems. So to recap this part, we quickly discussed some graphics concept. We looked at what we did in the past. This is two videos what you're going to see now, unless I'm able to merge it somehow. If somebody know how to merge it in YouTube, please let me know. We discussed and grew into frame buffer devices in several ways. Boot logo, psplash, we did both like in the past. Just cutting random stuff and like some black strides, and using static libraries that do all kind of like nice things, like the dark compiled library, like again having splash with busybooks fbsplash in a statically linked busybox, and having also using fbg, which also showed some source code for. I gave research tips for like how you experiment, especially since the combination of kernel configuration, unless you make a variable as kernel, and the packages that you need, it can take you time and it can take you tracing. And there, I put other videos in the Roman's YouTube channel, so you can see how you debug this kind of thing, like with sprays. I think some of the videos there are really like excellent and useful. And I really told you more than once that things take a lot of disk space because you should be mindful of it. So the next part will be dedicated to the direct rendering infrastructure or direct rendering model.